Hypothalamus Artificial Intelligence, HI. Digital transformation powered by real-time autonomous and intelligent algorithms. Presents its offering of services and products for mathematical modeling for Industry 4.0. The intellectual property of hypothalamus artificial intelligence is supported by our methodologies and technologies that has been used for 50 years developing and implementing highly complex mathematical model and decision-making systems at enterprise scale. HI has developed a robust library of successful algorithms for application development and use cases across large multi-regional enterprises. 80% of our process of computation systems generation is executed by AI agents, which ensures approach and implementation, at least 1000x times faster than an army of programmers. Our solution is universal, it is standardized, and it is easy to adapt and implement, satisfying the demands of fast digital transformation. Our methodology is based on artificial hypothalamus framework and use real-time autonomous distributed optimization, allowing algorithms to evolve, generating self-learning processes, minimizing human intervention. Our solution produce an average 10 to 15% reduction in operating cost. HI is business partner of leaders in producing high-productivity algorithms to solve optimization complex problems, like Gurobi Incorporated. The HI intellectual property it can be grouped into disruptive modeling methodologies, large-scale optimization algorithms, mathematical modeling using cognitive robots, and highly complex mathematical models for end users. Disruptive modeling methodologies. HI's vision of the future in terms of artificial intelligence, machine learning, and mathematical programming, is linked to parallel and distributed advanced analytics, which is the result of the joint evolution of computing, analytics and mathematics. From the point of view of evolution of computing and of the algorithms, it can be summarized as monolithic, unique mathematical model solved by an integrated algorithm into a single computer. Parallel, algorithms for large-scale mathematical problems, using the power of computing and parallels mathematics. Sparse, bottom-up modeling, based on the sparse structure of the connectivity of the systems and the human brains, and distributed, mathematical processing based on several agents, acting simultaneous and independently when received data. From the point of view of evolution of applied mathematics, it can be summarized as relational algebra, databases, deterministic optimization, and simulation. Artificial intelligence, machine learning, and advanced probabilistic, stochastic and robust mathematical programming, including mathematical programming with equilibrium constraints, and artificial brains, strong integration of artificial intelligence and mathematical programming. The evolution of analytics is the result of the union of computing and mathematics. It can be summarized as descriptive, contact reality, a single source of the truth. Largely reporting. Predictive, understand the most likely future scenario, and its qualitative business implications, including pattern recognition. Prescriptive, obtain the maximum business value, using optimization mathematical programming models. Cognitive, highly autonomous optimization and learning solutions that get smarter over time. HI is the creator of the concept of artificial entrepreneurial brains, which is supported by the development of parallel thinking, when a complex system must be analyzed. The artificial brains corresponds to the scientific foundations, more specifically mathematical fundamentals, that allow to connect multiple mathematical models, algorithms or robots, exchanging information between them to obtain a common goal, and act as holistic intelligence of the organizations, or parts therein. Like the human brain, the artificial brain is composed of the following artificial components: neocortex, hypothalamus, and hippocampus. This evolution may be summarized as the shift from artificial intelligence to augmented artificial intelligence. For the year 2000, approximately, the decision support systems, DSS, were conceptualized as a set of mathematical models that exchange information between them, working offline. The first commercial supply chain management solutions was developed based on DSS concept. The artificial brains is the evolution of DSS under the Industry 4.0 revolution that is conceptualized as a set of mathematical models that exchange autonomously information between them, working online, using distributed optimization. Artificial brains are backed by the technological capacity of computing. It is traditional to associate mathematical modeling with large-scale computing, which today is linked to cloud computing, integrated by supercomputers of bits, and by the birth of quantum computers, and its marketing process. The current state involves the integration of edge computing to implement highly complex mathematical models, this due to the growth of the power of the mini CPUs. When all the models that make up a company are solved using the concepts of real-time distributed optimization, an artificial hypothalamus is obtained. This is how the human brain faces reality, using multiple models of reality, acting permanently in parallel, to make decisions. The algorithm that simulates the hypothalamus is assembled by Optex, the highest cognitive robot, using the models that traditionally make up a decision support system. So, the artificial hypothalamus, a part of the artificial brain, is the algorithm that controls the workflow of the models of the decision support system. It includes the constraints that guarantees that the system is in the optimal path. This is based on the duality theory. In real time, the concept of an optimal point must be replaced by that of optimal path, as the one who is always close to the ideal optimal points. Large-scale optimization algorithms. HI develops algorithms to accelerate the solution of large-scale mathematical problems by partitioning and decomposition of complex systems, and the integration of physical models, differential equations, with large measurement systems. These algorithms are GDDP, Generalized Dual Dynamic Programming, PDS, Primal Dual Subrogate Algorithm, and MBD, Multi-Benders Decomposition. GDDP, PDS and MBD are part of the large-scale algorithms used by HI, which integrate high-performance commercial solvers with classical large-scale optimization methodologies, using cross-decomposition, giving rise to artificial hypothalamus, based on the autonomous real-time distributed optimization. Optex. Mathematical modeling using cognitive robots. It is a new vision of mathematical programming. Optex, making mathematical models as Lego models. In Optex, a mathematical model stored in an information system can be conceived as the union of mathematical components harmoniously integrated. There are two types of components, or objects. Basic mathematical definitions. Indexes, sets, parameters, and equations or constraints. Advanced concepts. Problems, models, decision support systems, and artificial hypothalamuses. These components can be stored in a relational information system. It permits their handling in a modular way, following the principles of relational information systems, and use structured query language, SQL, to manipulate the mathematical objects. This conceptualization is independent of optimization technologies, which allows to separate the formulation of the mathematical models from their implementation, using a specific optimization technology. The nuclear unit, the molecule, of a MP problem is the constraint, which is the result of integrating various types of atoms. Indexes, sets, parameters, and variables. Based on the constraints, more complex mathematical structures are built. Problems, sets of equations and/or set of subproblems. Models, sets of problems and/or set of submodels. Decision support system, set of models, and artificial hypothalamus. Considering that the problems are defined based on sets of constraints. If the modeler has built a database of equations, such as an equation store, he can formulate as many mathematical problems as the combinatorics of constraints that can be assembled. Traditionally, a problem is conceived as a monolithic set of equations. Under a modular conception, equations are components that can be shared by multiple problems. The important thing is that each equation works properly. This correct operation will be repeated in all the problems in which it is incorporated. If a store of equations exists, constructing a problem is limited to selecting the equations that make up the MP problem, and/or incorporate sub-problems that already have associated equations. This monolithic approach is easy to implement, however it does not allow the use of large-scale optimization methodologies. If it wants to use high-performance computing technologies, based on parallel processing, it needs to divide the mathematical model into multiple problems that represent the most elementary components of the physical system. This produces a significant gain in the solution time, and in the understanding of the inner operation of the system. To solve the model, it is necessary to select a large-scale optimization methodology that defines the processing of information in each problem. For example, the figure represents a mathematical problem related to the SAND-OP, sales and operations planning, that may be constructed based on 8 groups of equations: production, energy, maintenance, distribution, sourcing, human resources, financial, and sales and marketing. The view the systems, groups of equations, that must be included in the SAND-OP problem depends on many factors, because there is no revealed truth regarding what the SAND-OP problem is. Since the equations are defined in a database, the configuration of a problem is limited to selecting from the equation store which are the ones that the modeler want to consider in the model. These visions can change within an organization. In this way, the modeler can have multiple SAND-OP models which depend on the use you want to give to the models. These models can exist permanently, or they can be created on the fly at the time they are required to be used. A decision support system must group all mathematical models, predictive and prescriptive, that uses the enterprise. Therefore, a DSS can be defined by the set of models that integrate it. Associated with the DSS must be the flow of information between the models, since it is logical that the output of one model is used as the input of another model. The traditional is that these models are used by users in a manual way, except in cases of advanced optimal control in which the models can run permanently, in real time, in an infinite cycle. An example of the architecture of a production DSS in an organization is presented below. It is made up of 8 models. The diagram describes the data flow between models. Traditionally, these models are run with a certain frequency: daily, weekly, bi-weekly, monthly, and the implementation of the decisions depends on the professionals who must validate the results. In some cases, this validation is automatic. The model's interconnection chain has no limits, which is necessary for an organization based on advanced analytics. The concept of model integration is applied in multiple dimensions. For example, an integrated oil company can be conceptualized based on the operation of 4 businesses: production, crude oil transport, refining, and transport of derivatives. In this case, the complete model of the company corresponds to the integration of the 4 models. For example, the figure represents a mathematical model for a multi-business enterprise that operates 3 business: electricity, oil and gas. The integrated model of the company will be the union of the 3 super-problems. However, the modularity of the modeling allows to have individual models for each business. These models can exist as an integrated model, or as 3 individual models, one for each filial. In this case, the data communication for the integrated multi-business model is defined by the Lagrangian relaxation methodology. Under a hierarchical conception, each subsidiary can be divided into sub-businesses that can be planned in a coordinate or integrate manner. Coordinating, when each individual model connects with another model to send its optimal decisions resulting from an isolated planning. Integrating, when all models are part of a holistic model that produces the real optimal decisions for the enterprise. When all the models that make up a company are solved using the concepts of real-time distributed optimization, an artificial hypothalamus of the company is obtained. This is how the human brain faces reality. Multiple models of reality, acting permanently in parallel, to make decisions. The algorithm that simulates the hypothalamus is assembled by optex, using the models that traditionally make up a decision support system. The concept of artificial hypothalamus can be applied to solve real-life problems from multiple points of view. In the diagram, The artificial hypothalamus coordinates models corresponding to the multiple problems faced by a company, organized from the point of view of its administrative functions. Another point of view is the spatial distribution of the problem. In this case, an artificial hypothalamus is presented for an agro-industrial company that has multiple facilities, farms, concentrated food factory, meat products factory, and stores in the food market. The best way to make software is having to do it, is the goal of Optex. The high approach is aimed at developing cognitive robots that eliminate the tasks of computer programming, since the robot takes care of this process. This enhances the mathematical modeling capacity of the professionals. The basic technology developed by High is Optex Optimization Expert System, a cognitive robot that capitalizes the experience in mathematical modeling and generate artificial brains, or DSS, in many technological platforms, like IBM Alog, GAMS, AMPL, Mosel, AIMS, C, Python. Optex connects with the most advanced optimization algorithms like Gurobi, Plex and Express. Optex is a rapid application development tool, focused on the design, implementation, startup and maintenance of artificial brains, conceived as a union of mathematical optimization models, with information systems following the modern guidelines of object-oriented programming. Optex avoids the intensive use of resources for programming computers in the development and maintenance of computing solutions. Making very large-scale models by the traditional way, using a computer programmer, it is an impossible way, because the programmer only can write a limited number of lines of good source code per period. Maintaining these models can be more complicated than doing them, if more than one programmer intervenes in the process. Considering that Optex is a cognitive robot, that implies that Optex is able to produce infinite lines of perfect source code per period. Optex are oriented to state-of-the-art decision support systems, DSS, that integrate state-of-the-art technologies of advanced analytics and optimization, like mathematical programming, advanced probabilistic, machine learning, and artificial neural nets. Optex generates the large-scale algorithms required to implement high-complex mathematical models. And Optex generates the artificial hypothalamus, that is the central processor of an artificial brain. Highly complex mathematical models for end users. High uses Optex to implement all its end-user mathematical modeling applications. High OP Chain, optimizing the value chain, is a collection of specialized solutions, based in mathematical models, for optimize the value chain. The solutions offered can be grouped into manufacturing industry, industrial supply chain, bioindustry supply chain, demand chain, and human resource analytics. Heavy industry, oil supply chain, gas supply chain, power systems, smart grids, and mines supply chain. Transport and logistic. Regional planning, public health, and education. Financial institutions, and engineering projects. Like Herbert Simon, hypothalamus artificial intelligence believes that the computer-based mathematical modeling is the greatest invention of all times. Thank you for your attention.